Hello guys, welcome to another Python tutorial. In this video tutorial, we're going to discuss about one of the concepts in machine learning called linear regression. So we're going to discuss about multivariate linear regression. We're going to use scikit-learn, import data from scikit-learn itself from one of the data sets in scikit-learn. Then we're going to apply the linear regression concept and going to do some prediction. So let's get straight into it. So before starting our tutorial, so I want to let you guys know something. Like, this is the new Facebook page. I will post a link to this Facebook page in the description of this video. Go ahead and like this page and follow it. So I'll post all my new video tutorials in this page, so you could keep yourself updated. So yeah, like the page. Don't forget to like the page. Now let's start. So from first, we're going to import the dataset and we're going to visualize the dataset. We're going to see what's the size and all those. So first, from skill learn dot datasets import load Boston equals load Boston. So x is gonna be Boston dot data. Then y is gonna be Boston dot target. Boston. Okay. So now we loaded the data into x and y. So the x are going to be the feature and y is going to be the label. That's what it means. So let's go ahead and print them out. Print x first. F5, save, and F5. So it has to extract the data from the internet and it has to print it for us. So actually it has, if I'm not wrong, it has 13 features. And then the y, obviously you'll have only one label. So these are all labeled like one. So you'll have, like, if you go ahead and print out the shape of x and y, shape, comma, y dot shape. You will have equal rows and equal rows. So if there are like 100 columns in x, you will have 100 columns in y. Sorry, if you have 100 rows in x, you will have 100 rows in y. In terms of column, you will have like as many columns, like n number of columns in x, but only one column in y. So that's how the structure is normally. Save this and print F5. So you have 506 rows and 13 columns, and then 506 rows columns and 506 rows and 0 columns. It means you have only one column. So you know what this concept is like. We all studied this one in a school. You have I pick this one. Y, I make it darker. Y equals mx plus c. That's what this is all about. In our case, the label is still 1, but we have instead of m, which is slope, we call it w. They call weight. W1 x1 plus w2 x2 plus till w13 x13 plus c. This is constant. In this case, we call it a bias variable. So that's what this linear regression is all about. This is single. They call this one just linear regression. They call this one multivariant linear regression because we have multiple x values and only one y value. So now we imported the data. Now what we're going to do is we're going to import the linear regression model from sklearn linear model. So let's go ahead and do that. So let's import the from sklearn dot linear model import linear regressive import linear regression. So we loaded the data, and then we declare a variable for the linear regression model. So we call it like LR equals its linear regression. That's the model. We're going to import the linear regression model on this LR. LNEREGRESSI1 linear regression normalize equals true. So it's going to normalize your action. It's going to have a single unit for all the x values. So that's what the normalization is all about. So yeah, and then we're going to fit our x and y values to this LR so it can calculate the weight values. So that's called training in machine learning. So you're actually training the linear regression model with your x and y data that you're loading from the internet. So let's go ahead and do that. So LR dot fit your x and y value. In this case, it's going to be Boston data for predicting the price of a real estate. So now let's go ahead and print out these weight values. So we had, I think, if I'm not wrong, 13 x columns, right? So we must have 13 coefficients. So let's go ahead and print out the weight value. Print LR dot curve. Save, and also I'll print the shape. Print LR dot curve dot underscore LR dot shape. Fi shade. I typed shade shape. Okay, so we got like 13 like from x1 x2 so we got the weight values for all 13 x features, x1 x2 x3 x4. We got these weight values now. So these are all those values, and so we just calculated. We just want to know shape of this one, so which is 13. So we have 13 weight values here for all 13 features, x features, x1 to x13, which is this one. So now we have this one. So now it will use these data, and it will use this formula, and it will calculate this y based on the input that we're giving. That's what the machine learning is all about now. So let's create a new observation. Let's give it our own data. So let's create a NumPy array. Import NumPy as NP. So let's start from maybe here. Okay, we can also do it here. So observation, you call it anything you want. Observation equals np.array array. It takes array as an argument. So you have to give them 13 values. So let's give it like, I have a sample data with me, so I'm going to feed that. So you could also use the same. If not, you could open Boston database from the internet, and you could feed any of those values to this one and check whether it's predicting properly. So let's type the data. 1 comma 0 comma 1 comma 0 comma 0.5 comma 7 comma 59 comma 3 comma 200 comma 20 comma 350 comma 4. And for this one, D type, it creates a float, and then we're going to call the predict function and the hypothesis from the LR linear regression class, or linear regression class. Yeah, we call it a class. Is it wrong? I'm not sure. So from here we're going to import, we're going to call the predict method. So we're going to predict this. So it's going to predict it for us. Like before that, let's see whether this thing works. I just want to see the height. Print BOSTON. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, these are all the header for those 13 values in x1, x2, x3, x4, x5. And the other one, I think, is called the price. So for these, what's the price? So that's what this data set is all about, actually. So when we, for this set, what is the price? So we are feeding in CRIM, ZN, Indus, CHAS, NOx, RM, age, and all those. So according for these, for different value of these features, what's the price, which is a label. So I think it's in $1 million. So that's what we're gonna like predict here. Boston house price data, so it's actually price. So that's what we're gonna predict. So we're gonna predict the value for these three different. These data. So we created the array. Now we have to like predict the price for this array. Let's go ahead and call the predict function from LR. pr.predict. So we pass this observation. You could also pass an array in this one. See, but it has to be like you have to have 13 at least. So to make the proper prediction, if you are playing around, so if you don't know exactly what it is all about, so you have to pass that in to get some output. If not, it's going to throw you some error. F5 and press. Okay, we have some error. I just close this one. It's too hard for me to see. predict observation data type equals float. Do I have 13? 1, 2, 3, 4, 5, 6, 7, 9, 10, 11, 12, 13. Yes, indeed. Then why the heck it's giving me some error? Save FI. I got the output, but before that there's some error. So in which line replacing the error? Or something has been depreciated. Okay, so it's asking me to reshape it. So which? I think something has been depreciation warning. So everything is fine. So they keep upgrading the library, and then some methods will get depreciated. So we'll fix this one if possible in the next video tutorial. If not, we'll move on to the next concept. So this is actually the price in million, to $25.89 million for the criteria that we passed over here. That's it for this tutorial. Like, subscribe. If you have any doubts, leave the comments below. I'll try to answer it. If not, thanks for watching. Don't forget to like my Facebook page. I'll keep updating my page for each and every single video tutorial that I'm making. So I'll post the link to that video tutorial on the Facebook page. So You could keep yourself updated about the happenings in this channel. Thanks for watching. Bye for now. Talk to you guys. Shit. Talk to you guys in the next video tutorial.